Hello student, today I'm going to discuss with you this problem on reduction of coplanar forces. The question is the algebraic sum of the moment of the system of coplanar forces not in equilibrium. Okay, remember this is not in equilibrium means they are not at rest or moving with uniform speed is zero. So what is given here is that the algebraic sum of the moment of the forces system of coplanar forces is given to be zero about each 2 points A and B. So you take 2 points A and B here. Show that the algebraic sum of the result part, the algebraic sum means the resultant, the algebraic sum of the resultant of these two perpendicular to this point, this line AB. You join these 2 points A and B. Show that the result part or the resultant of these forces which acts perpendicular to AB is given to be 0. So what we do here, you take D here. D is the midpoint of AB, and we are taking D here as the origin. Since D is the midpoint of AB, so we consider D as the origin. So this one DB as the x-axis, with DB as the x-axis, okay, and D here as the origin. And the line through this line through D and perpendicular to AB as the y-axis. We consider this as the y-axis and this as the x-axis. So if you take D is the midpoint of AB, so take the distance from here to here to be A and from here to here to be A. So therefore the coordinates of A here will be minus A0, whereas here the coordinates of B will be A0 because they all lie along the x-axis. Now let this system of forces, coplanar forces, reduce to a couple G and about this point D, okay, about point D, and a force R which has components X. So this system of forces, let the system of coplanar forces reduces to a couple of moment G about D and a resultant R and a force R which has components capital X and Y along the x-axis and y-axis respectively. So now according to the question, the algebraic sum of the moments of the system about each of these 2 points is given to be 0. So let us take the algebraic sum, the sum of the moment of forces about, say, about first this point A, that is about A whose coordinates minus A0. This is according to the formula from the analytical method. Okay, we have this one, the relation about G prime. HK is there. The moment of the sum of the moment of the forces about G prime whose coordinate is HK is given to be this one. G prime is equal to G minus HY plus KX. Okay, you have to remember this formula about the point HK. Sorry, this is small, this is small, and this is capital Y, small y. So it's, in general it is given to be this. This is at the point HK, I mean HK. Let G prime is equal to G minus HY plus KX. Okay, but what is given here is that this point HK here, consider this point HK about the point A, this minus A0. And moreover, the sum of the moment of the forces about each of this point is 0, means G prime here will be equal to 0. So we have 0 is equal to G minus 0 Y plus minus H here, 0y, so it will be, sorry, it will be 0 is equal to minus, what is H here? It is minus, so I'll write first G here, G minus of minus A into Y plus what is k? K is 0. The coordinates here, this is 0. So 0 into capital X. Or you can write here, multiply throughout by minus sign. What you get is this minus into minus will give you plus. So plus ay, okay, ay plus g is equal to 0. Okay, or you can write here, this is minus ay plus g. So this implies that g here is equal to minus ay. Name it as equation 1. Now about the point ba, whose coordinate is a0, it will be b here, the sum of the moments, of the forces about B whose coordinate is A0. It will be again, because according to the question, the algebraic sum of the moment of the forces about 2 points, that is A and B respectively, they are equal to 0. So we have here, this is again G minus AY plus 0x, or you get here G. This implies that G is equal to A. Name it as equation 2. Now from 1 and 2, to eliminate G, what we do is you just add this 1 and 2. So 1 plus 2 gives you G minus AY, okay, is equal to AY, or bring it to this side, you get minus twice ay is equal to 0, implies that a cannot be equal to 0, 2 cannot be equal to 0, implies that y is equal to 0. So therefore the result part of the sum of the result part perpendicular to AB is equal to 0. Why perpendicular to AB? Because what is y? Y is the component of the forces along the y-axis. So this shows that the result part of the forces along the y-axis or perpendicular to AB is equal to 0. Next question is this one. The sum of the moments of the system of coplanar forces about 3 non-collinear points in the plane of the force is the same, not equal to 0. So the sum of the moments of all the system about 3 non-collinear points, it is given to be 0. So what we have to show is that the system is equivalent to a couple, that is the resultant R here must be equal to 0. So let us assume that this system of forces, of coplanar forces, are acting about these 3 non-collinear points A, B, C. There are 3 non-collinear points. This is point C. And we consider B here as the origin whose coordinate is 0, 0, along BX as the x-axis and BY as the y-axis. And the point C here is having a coordinate A0, and alpha A here it is having a point alpha, beta, coordinates of A. So let us suppose that the system of coplanar forces reduced to a force R. We assume that the system of this whole coplanar forces reduced to a force R which has component capital X, which has components capital X and Y along the axis, okay, along the axis, and together with a couple, okay. Together with a couple about the origin B here. We are considering B as the origin, okay? Origin. So we assume that the system of coplanar forces acting on these 3 non-collinear points reduced to a resultant R having component X and Y along the x-axis together with a couple G acting about the origin, where the origin here we consider it as 0, 0. Now we take the moment of the system of forces about these 3 points, that is, we take the moment of the forces about A, B and C. So number 1, let us see sum of the moments of the forces about B, say, or about the point B 0, 0 is given to be this one. according to the formula, it is g minus hy plus kx, which is equal to, what is g? G here, it will remain as it is, and h here is 0, y plus 0, k. So this implies that the moment of the forces about B will be equal to minus g. Now sum of the moment of the forces about the point A, whose coordinate is, let me check right about C, whose coordinate is a0, it will be equal to what again? G minus, use this formula, a here is a y plus 0 k. So this will be equal to g minus a y. Okay. Next is the sum of the moment of the forces. The sum of the moment of the forces about A, whose coordinate is alpha beta, so it will be equal to g minus alpha y plus beta x. Okay. But what is given in the question is that the algebraic sum of the moments of all the forces about 3 non-collinear points, they are equal. Okay, so means that the sum of the moment of the forces about A is same as the sum of the moment of the forces about B, which is same as the sum of the moment about the forces about the point B. So therefore about point A is this. So, and what about the point C here? So this implies that minus g, we have g is equal to, okay, g is equal to g minus ay. That is, this is sum of the moment of the forces about the point B, this is sum of the moment of the forces about point A, and which is same as the sum of the moment of the forces about the point Y, point A. So from here, compare first these two. G is equal to g minus ay. G and g can be cancelled, implies that ay is equal to 0, minus ay is equal to 0, but a can never be equal to 0, so this implies that y is equal to 0. Substitute the value of y here to be 0, compare it with this g here. So g, now compare this with this, so you have g is equal to g minus ay plus beta x. In order to obtain the value of x now, g can be cancelled, so this implies that minus ay plus beta x is equal to 0, but y is equal to 0, so this implies that beta x also must be equal to 0, but beta can never be equal to 0, implies that x is equal to 0 here, since you can write since y is equal to 0. So what does it shows here? Capital Y, that is the component of the forces along the y-axis, is given to be 0, and the component of the forces along the x-axis is also equal to 0. Hence, this implies that capital R, which is called the magnitude of the forces of the resultant force, that is x square plus y square, will be equal to 0. So hence the whole system of algebra, because what we have assumed here is that let the system of coplanar forces reduce to a couple together with a resultant are having component x and y along the axis. But what we have shown here is that capital X and capital Y is equal to 0, implies that R is equal to 0. So the whole system of forces acting at these 3 non-collinear points reduced to a couple only. Okay, I hope it is clear.